Hi, I'm Sandra, and in this video I want to explain to you what polymorphism is. I'll also look at the reference variable and explain the rules around that, and discuss polymorphic method invocation, or as Microsoft like to call it, dynamic method dispatch, or simply which overridden method gets called. So I'll discuss all of that. Firstly, when I think of polymorphism, what it means many forms. So what I think of polymorphism is a shape array, an array of shapes, an array containing circles, triangles, rectangles. I have some code written up here already, so I'm going to quickly go through that. Firstly, I have a parent class called shape. It's abstract. I'll discuss abstract methods and abstract classes in a separate video. It's abstract, which means it can't be instantiated. It exists to provide common functionality, common methods, so that child classes can inherit those. So this shape class, I'm trying to keep it simple, so it just has a color member variable. Color, maybe I'm not keeping it simple, is an enum. So an enum made up just of a list of different color values. Also in the shape class, it has constructors. Constructors are not inherited, but they can be called from child classes by using the super keyword. There's a get and a set for color, and there's a toString. So the toString will be overridden in child classes, so we'll be looking at that in more detail. The toString, so what it's going to print out is going to print out something similar to a red circle, a green rectangle, a brown triangle, that kind of thing. To get the name of the class, I've stuck in a little bit of fancy code here, and color is an enum, and I've turned the enum into a lowercase word, so color.toString.toLowercase, so that's how to convert an enum into lowercase. And then to get the name of the class, this .getClass.getSimpleName, that will return the name of the class that's been used, whether it be a rectangle, circle, or triangle. Now to look at the other classes, rectangle is made up of height, width, and area. There are constructors, one that takes nothing, one that takes all of those three member variables, getters and setters, and I have a toString that's overridden. So this toString will return the member variables for this class. So because it's a rectangle, it will return the size and the height and the width and the area there. Also, circle. Circle has a radius, so the constructor takes in the radius. There's a get and set for radius, and the toString includes the parent's toString method, so that gives off like a red circle, and the radius is added on. Triangle. Nothing new added into triangle, but just to demonstrate that a class can be a subclass, so it can extend another class and not necessarily add in anything. That's perfectly legal to do that. It does, because constructors aren't inherited, it does need to add in its own constructor where you can set a color at the same time as creating a triangle. I have a main. So what I'm going to do here in main, I'm going to create some objects and I'm going to put them into an array of shapes. So to do that, firstly I'll create a rectangle. Rectangle or1 equals new rectangle. I'm taking a look here at the constructor, so control space gives me access to what constructors are available. So I can pass in a color. That's an enum, so my enum's in the same package. So let's have an orange, height 5, width 10, rectangle. Next object, let's create a circle. Again, control space to get the constructors that are there to see what order I have to pass in the values. Color dot. Let's have a red circle, radius 7. I'll create a triangle as well. Triangle T1 equals new triangle. I can pass in the color dot, and we're going to have a green triangle. Now what I'm going to do is pop those into a shape array. So the data type or reference variable for the array is going to be shape. So all shapes equals curly brackets, and if I have any objects created before this line, which obviously I have, I can just use the reference variables for those. T1, or inside the curly brackets I can also create another, let's pop in another circle here, and the constructor there I know is a color dot, we'll go with pink, and a radius for a circle there, we pop in 6. So inside the curly brackets, I can pass in a reference to an object that's already been created, or I can create a new one in here by calling the constructor. So let's take a look at this reference variable shape. So this is known as maybe polymorphic, in which what it means is that this array can contain many different forms. The reference shape, which means that inside the array can be anything that passes the is-a test, and that means something that instantiates shape or a child class of shape. Now, I can't instantiate the shape class. I can't go shape s equals new shape because I've made it abstract. So it exists just to provide common functionality to those child classes. Just a little bit more on reference variables before I go any further on this. Say I have a circle. I want to create a circle. The most obvious way is circle C2 equals new circle. So here the reference type is the same as the object type. That's my object on the right hand side. That's the reference on the left. They're the same type. But what else can it be? It can be the parent. So shape S2 equals new circle. And it can be the parent again, as the parent of shape is object. Object O equals new circle. So these are all valid declarations. Reference on the left can be the same or a parent. They are all valid reference types for a circle object. Now, where this will make a difference, depending on what the reference type is when I go to call a method. So if I do O dot, I'm only going to get access to the methods that are in the object class. If I have S2 dot, it's going to give me access to anything in the object class and the shape class. So I know that circle has a radius, but I can't access the getRadius method on a shape reference or on an object reference. But if I put in C2 dot, that will now give me access to any methods in the circle class, so the second getRadius, toString, which I've overridden. It'll give me access to anything in the shape class. I think I've overridden everything. And it'll give me access to any methods in the object class. So the reference type, it is important for which method you want to call. What I'm going to do now is loop through that shape array that I have. So I'm going to use the for each loop. So for colon, right hand side of the colon, the name of the array that I'm looping through, and the left hand side of the colon, this is where I declare one of what's in that array. Now the array is declared as type shape, so what I'm going to do here is to cover all angles. I declare a shape reference. So when it's looping, all shapes might refer to the rectangle, next will be the circle, and so on. Well, shape reference will cover all of those. So if I'm looping through a shape array, the reference type here on the left on my for loop has to be the same, so shape. As it loops, this S reference will refer to each object as it loops. So as it loops, S will refer to first that rectangle, that orange rectangle. Secondly, will refer to that circle object, the red circle. Thirdly, a green triangle. And lastly there, the pink circle. So that's what S will refer to. When I'm inside here, if I do S dot, I only have access to the methods in the shape class and anything from the object, so anything up above the hierarchy. If I wanted to call it a circle method, I don't have access to that on that reference. Now, so what I'm going to do here, and I'll show you how to get around that in a second, I'm going to print out, if I just print out S, what's happening here is it will implicitly call the toString method. Now, so in terms of polymorphism, I have a shape array made up of many different forms, many different types of objects. When I call S.S here, that implicitly calls the toString method, the question is, which method gets called? Now, this is referred to as polymorphic method invocation, or Microsoft call it dynamic method dispatch, or I just call it which method gets called. Now, just firstly to note that the toString method has been overridden. It is in the shape class. It's also in the object class. It exists firstly in the object class. The shape class puts in its own, replaces it, known as overriding it. Each of my child classes, except for triangle, each of the child classes, circle overrides the toString and rectangle overrides the toString. So which overridden method gets called? That is determined at runtime, and the simple answer is it's based on the object type. So at runtime it's based on the object type. When this executes, S will refer to the rectangle first of all. So which overridden toString method gets called? The one that's in the rectangle class. Then S will refer to the next object in the array, the circle. Which overridden method gets called? The one that's in the circle class. So it depends on which object it's referring to. Next is the triangle. Which overridden method gets called? Well, it depends on the object type again. It's a triangle. Now in this instance, I did not override the toString in the triangle class, but it inherits the one from toString. So it will actually, or it inherits the one from shape, apologies. So it will just execute the one that's in the shape class. So remember, inheritance is as if the method from the parents class gets copied in. And finally, S will refer to the circle object. Which overridden method gets called, again, depends on the object type, and circle has overridden the toString method. So when I run that, we can just show you the output. So 4 lines for 4 toStrings. Rectangle first, rectangle, the size and the area. Next, the circle. Third, the green triangle. And finally, the circle again. Now, I did not override the toString in the triangle. It inherits the one from the shape class. And in the shape class, I cleverly put in, so I get A, green, that's got from the color enum, turned into a string and into lowercase, so it looks nicer. And the current object, so this means the current object. The current objects get class. That will return a class type. It just gives you more information, more methods that you can use. Get class, get simple name. So that gives this, the current object's class's name. And that's how triangle is output there. Now, so just 2 more things to discuss. The polymorphic method invocation, so basically again, which overridden method gets called. It depends on the object type, so it goes into the correct class at runtime depending on which object it is. That only applies to overridden methods. It doesn't apply to instance variables like the color, and it doesn't apply to any static variables or static methods. If you've an instance variable or a static method, it depends then on, it goes to whatever the reference type is. So it's a shape reference, it would go into the shape class if you're referring to a member variable, or not a member variable, yes, a member variable or a static method. It's only when it's an overridden method will it go into the correct, going down into the child class at runtime. Now, one more thing I want to do here, and that is show you what if when it's looping, I actually want to print out the circle's radius. So down here I want to print out the radius of the circle is, so print out the radius of the circle is. Now the problem here is I don't want to print this out when I have a rectangle or a triangle, only when I have the circle. So how do I do that? And another problem, when I'm in this loop, I only have an S shape reference. So when I do S dot, I don't have access to anything got to do with radius. So what I have to do is, there's 2 things I have to do. One is I have to convert this reference into a circle reference, and that will give me access to any methods in the circle class. So to do that, that's called casting. So before that, I type in what the type I want to cast to, circle. I need an extra set of brackets because the dot is precedence, so I need to make sure the cast happens first. And now, when I type that dot, I have access to get radius. That alone will cause a problem. I'm just going to run it to show you what the problem is. The first object is a rectangle. And when I try and cast the S reference, which is a shape, into a circle, when it's referring to a rectangle, it causes a ClassCastException. Let's say that again. In my loop, S is a shape reference. The first object it refers to is rectangle. I've code here that converts it, casts it from a circle, or casts the reference, from a shape, but it was referring to a rectangle, into a circle type, and I can't have a circle reference referring to a rectangle object. That causes a ClassCastException. So that ClassCastException will occur when you're trying to convert the reference to like one of the siblings. If you can imagine these as siblings, they don't like being referred to as one another. So that will cause that problem. So the fix for that is I put in an if statement and I say if S instance of circle. So I'm saying if S refers to a circle object. So when it's working, if S is actually a circle, if S refers to an actual circle object, then do the cast, and that will fix it there. So as it's looping, S will refer to a rectangle the first time around. Is that a circle object? No. Second time around, is this a circle object? Yes. Well, then it's safe to convert or cast from a shape into a circle. It's known as downcasting because you're going down the hierarchy. It's fine to do cast from a shape into a circle when it does in fact refer to a circle object, and now that getRadius is being called on a circle reference. So that's how I can get access to one of the child objects method when I'm using polymorphism here and I want to get to one of the child's particular methods. So that is showing polymorphism, just a quick summary there. Polymorphism refers to, I think of shape array. So I have a shape containing many different child objects. And when I'm executing my code, I'm calling the toString here. Which one gets called depends always on the object type. So it's nothing got to do with the reference type. It depends on the object type. It'll call the specific one in the child class at runtime if it has been overridden. And then if you want to get to one of the child class's methods that's not in the shape class, so on the shape reference, that casting needs to happen to change the reference type so I can get into the correct object at runtime. And that is polymorphism. If you have any other questions or want anything explained, please pop them down below the video. Thank you.